Critical numbers. So what is a critical number? Sometimes they're also called critical points. It's the same thing, just different phrasing. So critical numbers. Critical numbers are where the derivative is 0 or the derivative does not exist. So what that looks like is f prime of c equals 0 or f prime of c does not exist. And if that happens, then we have a critical number. Now we need to note something. We've had a couple examples where we've had a cusp or a sharp point where we know we can't have a derivative, but we've been looking at it as a maximum or a minimum. So the thing to note here is you can still have a max or a min when the derivative does not exist. It can still be a cusp or a sharp point, and it can still be a max or a min, even if the derivative doesn't exist. So that's why a critical number is also including where the derivative doesn't exist. So critical numbers occur where we have the derivative equal to 0 or the derivative not existing. So how do we find those? How do we find those critical numbers? Well, right here we have our equation, f of x equals 5x squared plus 4x. So the first thing that we need to do is find the derivative, because in either case, we need to consider the derivative. Now, if we think about this one for a second, this is a continuous function. It would be a parabola because it's to the second power. So it's a continuous function. There's no jumps, there's no breaks, there's no holes, we're okay. It's a continuous function. So what that means is we can look to see where the derivative will be 0, and there's nowhere that the derivative would not exist. So let's start with our derivative. So f prime of x equals, bring down your power, 5 times 2 is 10, subtract 1, 2 minus 1 is 1. X, 4 times x, bring down your power, so 1 times 4 is 4, x to the 0, so just 4. So 10x plus 4 would be our derivative. So now we need to figure out where our derivative is equal to 0. So where does 10x plus 4 equal 0? So subtract 4 from both sides, divide both sides by 10, and it looks like we get negative 4 over 10. Now we should simplify that. So that will be negative 2 over 5 is equal to x. So that means that our critical number is negative 2 over 5. It also means this would be our only critical number because it is a continuous function. So there is nowhere that the derivative does not exist. So our critical number in this case would be negative 2 over 5. Let's try the next one. So here we have x to the third plus 3x squared minus 24x. So the first thing that we need is our derivative. Bring down the power, subtract 1, bring down the power, 3 times 2 is 6, subtract 1, bring down the power, subtract 1. There we go. Set it equal to 0. Now I'm noticing as I rewrite this that all of these terms are a factor of 3. So if I pull a 3 out, I'll be left with x squared. Pull a 3 out, I'll be left with 2x. Pull a 3 out, I'll be left with minus 8. What's good about that is I can divide both sides by 3, and then it will make my factoring step a little bit easier. So now I need to factor. We need two numbers that multiply to 1 for 1x squared. We need two numbers that multiply to negative 8, and we need the middle term to come out to positive 2. So 4 times 2 is 8, so negative 2 and positive 4 looks like it'll work. So now we can take both of our terms and set them equal to 0. So 0 equals x minus 2, and 0 equals x plus 4. So this will give us 2 equaling x, and this will give us negative 4 equaling x. Again, continuous function. There's no denominator issues, there's no gaps, there's no jumps, so we're okay. So it looks like x equals 2 and x equals negative 4 will be our critical points, our critical numbers. Let's try the next one. This one we have an absolute value. So we need to think about this. If we have t greater than or equal to 4/3, then the result is going to look like 3t minus 4. Because it'll equal 0 where we have the center right here. The absolute value would be 0 where we have 4/3 if we solve this for t. So that 4/3 is what's going to be splitting it from taking the absolute value of a positive or taking the absolute value of a negative. So if t is less than 4/3, then we're going to be taking the absolute value of a negative. So it would look like the opposite of 3t minus 4, which would look like 3t plus 4. So now we got to think about this for a second. If we consider the derivative, well, the derivative of 3t is just 3. The derivative of 4 is 0. So now let's think about that in terms of what we have over here. So if our value is going to be less than 4/3 right here, then the derivative would be -3. If the value is going to be greater than or equal, then the derivative would be +3. But the moral of the story is there is no number that's going to get us a derivative of 0. So g prime of t is never equal to 0. Because it's always either 3 or -3. But we will have a corner at 4/3 because 0 equals 3t minus 4. So 4/3 equals t. So we'll have a corner at 4/3. So that means that 4/3 is still a critical point, a critical number. Let's look at number 8. This one is tricky. When you look at this one, your first thought might be, let's see if we can factor. If we tried to factor this denominator right here, which is a great idea to try if you see something that looks factorable. I need y and y. I need two numbers that multiply to +1. So -1 and -1 are my only options. But that's going to give me -2y. So this denominator is not going to factor. Good idea, but that won't work. So now we need to try something else. Well, we need the derivative equal to 0, so let's see if we can take our derivative. This is a quotient rule. So the derivative says bottom times the derivative of the top. The derivative of this top piece up here is just 1. Minus the top times the derivative of the bottom. So the derivative of the bottom would be 2y minus 1. All over our denominator squared. So that's just our derivative. All we figured out so far is just our derivative. But we need to think about this for a minute. Are there any values that are going to make this denominator 0? Well, let's see. Let's see if we can find some. So if we are trying to make this denominator 0, we could graph it, and then we could look at it and see if it ever crosses the x-axis. So that would work. We could take the quadratic equation and see if we're ever going to get 0. That would work. If you try either of these values, I'll let you know that it will never be 0. So y squared minus y plus 1 never equals 0. So there's no critical points, there's no critical numbers that are going to come from the denominator. So when we set this whole big monstrosity up here equal to 0, what we're really concerned with is the numerator, because we could multiply both sides by this denominator right here, and the denominator would cancel, and 0 times is going to cancel. So this numerator of y squared minus y plus 1, and then we have to FOIL this over here. So let me just do that FOIL real fast, and then we'll do the subtraction. So y times 2y is 2y squared. I'm just going to put it up here. Y times -1 is minus 1y. -1 times 2y is minus 2y. So -1 minus 2 is minus 3y. -1 times 1 is plus 1. Okay, so now I need to distribute this negative to this whole thing up here. So that will look like minus 2y squared plus 3y minus 1. So let's see, I like a good canceling. So let's see if we can find a cancel. Not too much. This one and this one will cancel, but we can at least do some combining of like terms and clean up the rest. So if we do that, it looks like we will have y squared minus 2y squared. So that's negative y squared. negative y plus 3y, that looks like it'll be plus 2y. So that's going to go 0 equals, let's factor out a y. So then we're left with negative y plus 2. So now we can do our two parts. So 0 equals y, and 0 equals negative y plus 2. I'm almost out of space, so I'm going to have to finish this one over here. So negative y plus 2 means that y equals 2. So we're going to have two critical points for this one. We'll have our two critical points at y equals 2 and y equals 0. And those are from right here and right here. And those are both from the numerator as we solved it down, because we canceled our denominator because there were no critical points that were going to come for our denominator. And we can multiply with our 0 here, both sides by the denominator, and it would cancel out.